Welcome to my channel. Today we are learning vector in mathematics. Dear students, today you are learning scalar or dot product of two vectors. Now look at the graph and answer the following questions. The first question is, what are the coordinates of the point A and B? Okay, your guess is correct. The coordinates of A is 3, 5 and the coordinates of B is 8, 2. Now second question is, what are the position vectors of the point A and B? Position vectors of the point A and B. Okay, the position vectors are also 3, 5 and 8, 2. Now third question, move to the third question. The third question is that multiply x coordinates of the point A and B and y coordinates of the point A and B separately. Okay, when you multiply, find the sum of the product of the x coordinates and y coordinates of the point A and B. Okay, when you find the sum, please look at there. Is the sum is in 0 form or 0 form? It means whether the sum is in number form or ordered pair form. Now, when you study all these things, you can conclude that the sum of the product is obtained in scalar form. Okay, the sum of the product is obtained in scalar form. It means when we multiply two vectors, the product comes in scalar form. Dear learners, in this chapter we are learning some formula based on scalar or dot product of two vectors. Now, let us think two vectors be vector OA is equal to 2, 4 and vector OB is equal to 6, 3. Vector OA is equal to 2, 4 and vector OB is equal to 6, 3. Then multiplying x coordinates and y coordinates separately, we get 12 and 12. Now when we add both of them, the sum is 24. It means when we multiply two vectors, the result comes in number form, means scalar form. Thus, we can say that dot product of two vectors gives the result in scalar form. So it is known as scalar product. If vector A and vector B are two vectors and theta be the angle between them. Vector A and vector B are two vectors and theta be the angle between them. Then the dot product is defined as vector A dot vector B is equal to modulus of vector A dot modulus of vector B cos theta, or it is equal to AB cos theta, where theta is between 0 to pi radian. Here A is equal to modulus of vector A and B is equal to modulus of vector B, which are the magnitudes of vector A and vector B separately. So finally we can say that vector A dot vector B is equal to modulus of vector A dot modulus of vector B cos theta. This is the formula for finding the product of two vectors. Dear learners, in this chapter we are learning geometrical interpretation of a scalar product. Now look at the picture and let vector OA is equal to A and vector OB is equal to B and theta be the angle between them. Then in the figure we can see AD perpendicular OB, AD perpendicular OB and BE perpendicular OA. BE perpendicular OA. Now we can write vector A dot vector B is equal to modulus of vector A dot modulus of vector B cos theta, or that is equal to AB cos theta. Here A is equal to modulus of vector A and B is equal to modulus of vector B, or we can write as OA multiply OB cos theta, or that is equal to OA multiply OE. Here OE is equal to OB cos theta. Now we can say vector A dot vector B is equal to magnitude of vector A multiply projection of vector B on vector A. Similarly, we can say vector A dot vector B is equal to magnitude of vector B multiply projection of vector A on vector B. This is the geometrical interpretation of a scalar product of two vectors. Dear learners, in this chapter we are learning condition of being perpendicular. Look at the picture. In the figure we have OB perpendicular OA, OB perpendicular OA. So angle AOB is equal to 90 degree. Now according to formula, vector A dot vector B is equal to modulus of vector A dot modulus of vector B cos theta. When cos theta is equal to cos 90, the product is equal to 0. So we can write when two vectors are perpendicular to each other, their scalar products is 0. Yes, this is the condition of being perpendicular. When vector A dot vector B is equal to 0, then the vectors become perpendicular. Dear learners, in this chapter we are learning scalar product of unit vectors I and j. Now look at the picture. Here let us think vector I is the unit vector along x-axis and vector j be the unit vector along y-axis. Then we can say angle between vector I and vector I is 0 degree. Angle between vector j and vector j is 0 degree. And angle between vector I and vector j is 90 degree. Okay. Vector I and vector I. Angle between vector I and vector I becomes 0. Angle between vector j and vector j also becomes 0. Angle between vector I and vector j becomes 90 degree. Now we can write vector I dot vector I is equal to 1. Similarly, we can write vector j dot vector j is equal to also 1 and vector I dot vector j is equal to 0. Dear learners, now we are learning scalar product of two vectors in terms of their components. Let vector A is equal to x1 y1 and vector B is equal to x2 y2. Then writing vector A and vector B in the form of x vector I plus y vector j, we have Vector A is equal to x1 vector I plus y1 vector j, and vector B is equal to x2 vector I plus y2 vector j. Now, vector A dot vector B is equal to x1 vector I plus y1 vector j dot x2 vector I plus y2 vector j. Now, multiplying both, we can easily get these terms, and when we simplify, vector A dot vector B is equal to x1 x2 plus y1 y2. We can write vector A dot vector B is equal to x1 x2 plus y1 y2, which is the scalar product of two vectors in terms of their components. Also, we can write cos theta is equal to vector A dot vector B over modulus of vector A dot modulus of vector B, that is equal to x1 x2 plus y1 y2 over AB, where modulus of vector A is equal to A and modulus of vector B is equal to B. So finally, we have a formula vector A dot vector B is equal to x1 x2 plus y1 y2. This is the formula of scalar product of two vectors in terms of their components. Dear learners, in this chapter we are discussing square of a vector. Let vector A is equal to x1 y1, then vector A dot vector A is equal to x1 y1 dot x1 y1, that is equal to x1 x1 plus y1 y1, or it can be written as x1 square plus y1 square. So square of vector A is equal to x1 square plus y1 square. This is the square of a vector, where square of vector A is equal to A square, that is equal to x1 square plus y1 square. But we have to understand that vector A not is equal to A. But we can write square of vector A is equal to A square. Now we are learning properties of a scalar product of vectors. Let vector A, vector B, and vector C be any three vectors, then the scalar product satisfies the following relation. The first one is commutative property. Vector A dot vector B is equal to vector B dot vector A. This is the commutative property. And the second one is distributive property. The distributive property states that when the sum of vector B and C multiplied with vector A, that is equal to vector A dot vector B plus vector A dot vector C. Scalar product satisfies some of the algebraic relation, and the relations are given here. The square of vector A plus vector B is equal to A square plus 2 vector A dot vector B plus B square. Similarly, the square of the difference of vector A and vector B is equal to A square minus 2 vector A dot vector B plus B square. And the third one is when we multiply the sum of vector A and vector B with the difference of vector A and B, the product is equal to A square minus B square. The vector follows some of the algebraic relations and some other relations that we discussed here in this chapter. Dear students, in this chapter we are learning some examples related to the scalar product of vectors. The first example is given here. let vector m is equal to minus 5, 2 and vector n is equal to 2, 7. Then we have to find the angle between vector m and vector n. Also, we have to find square of vector n and square of vector n. This can be solved as let vector m is equal to minus 5, 2, that is equal to x1, y1, and vector n is equal to 2, 7, that is equal to x2, y2. Now, product of vector m and n is equal to x1, x2 plus y1, y2, that can be written as 4. Again, modulus of vector m is equal to under root x1 square plus y1 square, that is equal to under root 29 unit. Similarly, modulus of vector n is equal to x under root x2 square plus y2 square, which can be written as under root 53 unit. Let theta be the angle between vector m and vector n. Then by formula, we can write cos theta is equal to product of vector m dot and vector n over modulus of vector m dot modulus of vector n. That can be written as 4 over root 29 dot root 53. So by simplification, we can write theta is equal to 84.14 degree. Again, we have to find square of vector m, that is equal to square of modulus of vector m, which can be written as 29, and square of vector n is equal to square of modulus of vector n, that can be written as 53. So finally we have the answer. This is the answer which is required. Now we are discussing the second example, which is given here. If vector A is equal to 6 vector I plus 2 vector j and vector B is equal to vector I plus k vector j are perpendicular vectors, then we have to find the value of k, which can be solved as given vector A is equal to 6 vector I plus 2 vector j, that can be written as 6, 2. Suppose this is equal to x1, y1 and vector B is equal to vector I plus k vector j, which can be written as 1k, and suppose this is equal to x2, y2. Now, since vector A and vector B are perpendicular to each other, then we can write vector A dot vector B is equal to x1, x2 plus y1, y2, that is equal to 0. When we solve this problem, we can find the value of k is equal to minus 3. This is the required answer. Now we are solving the third example, which is given here. If coordinates of A is 2, 4 and coordinates of B are 2, 2 and coordinates of C 4, 2 are 3 points, we have to prove AB is perpendicular to BC. This can be solved as the 3 points are A24, B22 and C42. To prove, we have to prove AB perpendicular to BC, which you can see in the figure. AB perpendicular to BC. Now, vector AB. The components of vector AB can be derived using the formula x2 minus x1, comma y2 minus y1. By replacing the value of x1, y1, x2, y2, we can get vector AB is equal to 0 minus 2. Similarly, we can find the components of vector BC by using formula x2 minus x1, y2 minus y1 and replacing the value of x1, y1 and x1, y1 and x2, y2, we can find vector BC is equal to to 0. When we multiply vector AB with vector BC, the product is 0. It means the product of two vectors is equal to 0, which implies that vector AB and vector BC are perpendicular to each other, because when vectors are perpendicular to each other, the product of those vectors becomes 0. Hence, AB perpendicular BC proved. Dear learners, in this example, we have a question. If vector A plus 2 vector B and 5 vector A minus 4 vector B are orthogonal to each other, and vector A and vector B are unit vectors, we have to find the angle between vector A and vector B. Now it can be solved as, let the given vectors are vector M is equal to vector A plus 2 vector B and vector N is equal to 5 vector A minus 4 vector B. We have modulus of vector A is equal to 1 and modulus of vector B is equal to 1, because vector A and vector B are unit vectors. It is given to us. So, again, vector M and vector N are orthogonal to each other. Orthogonal means perpendicular to each other. Then vector M dot vector N is equal to 0. Now replacing the value of vector M and N, we have vector A plus 2 vector B dot 5 vector A minus 4 vector B is equal to 0. When we multiply and solve, we can find that vector A dot vector B is equal to 1 by 2. Now let the angle between vector A and vector B be theta. Then by formula, cos theta is equal to vector A dot vector B over modulus of vector A dot modulus of vector B. When we replace the value of vector A and vector B and modulus of vector A and modulus of vector B, we can get cos theta is equal to 1 over 2. When cos theta is equal to 1 over 2, then theta is equal to 60 degree. This is the required answer. Thanks for watching our channel. Please don't forget to subscribe the channel and share the videos.